This lesson covers section 5.1, day 1, and the first thing we're going to start out with is going over the discovery of some of these Pythagorean identities and how to manipulate them and solve for certain terms within the Pythagorean identity. And then we're going to use these formulas to do some basic simplification of trig expressions. So let's start off here with a reminder of what tangent theta was. When we were working with unit circle, recall that we would say tangent theta was y over x. So this unit, I want us to focus more on using trig functions to define certain trig functions. So tangent theta is going to be sine over cosine. Cosecant was the reciprocal of the y values in our unit circle, which we will rewrite as 1 over sine theta, or the reciprocal of sine. And we'll do that for the other ones as well. So cotangent we know is the reciprocal of tangent. So since it's the reciprocal of tangent, I know that it's just going to exchange the cosine to be in the numerator and the sine to be in the denominator. Okay. And again, using the unit circle, cosine were our x values and sine were our y values. Secant is the reciprocal of cosine, and we can also recall 1 over x. So those are the main ones we're going to be using on our first day. But let us look into remembering what the Pythagorean identity looks like. So if you recall on our unit circle, let's see if I can just do a brief sketch here. Okay. Now all the radii of our unit circle, and that is totally not in the middle, but you get my point. All the radii of our unit circle were of length 1. So let's say if I did the 45, 45, 90 degree angle. Remember when we did some construction? The distance from here to here, let's call it some x distance. Now I know we know it's square root of 2 over 2, and we did all that discovery distance, and again, my graph is not drawn to proportion. Let's call the distance vertical, the y distance, and we know that the unit circle has a radius of 1. So since we have a 90 degree triangle, using Pythagorean theorem, we can say, which is leg squared plus leg squared equals hypotenuse squared, we can use the labeling of our triangle and write x squared plus y squared equals 1 squared, which simplifies to x squared plus y squared equals 1. If I substitute the x and y using trig functions, the x is my cosine theta, and since it's squared, I need to put a squared. The 2 goes right in between the cosine and the theta, plus my y value is the sine theta, again it has to be squared, equals to 1. So this is the development of my first Pythagorean identity. This is one of 3 that we're going to go over, okay? And I want you to see how this works. So note that we said that this was the point square root of 2 over 2 comma square root of 2 over 2, if you recall your unit circle points. So notice how it will satisfy this equation. So my cosine theta at that angle would be the x value, which is square root of 2 over 2, right? And if I squared that, and the same thing with my sine value is the y value, which so happens to be the same number. Well, the square root of 2 to the second power is just going to be a 2, and 2 to the second power is going to be a 4, and that's the same thing. And we are checking to see if it's going to equal 1. Well, 2 plus 2 is 4 over the common denominator of 4, and 1 indeed is equal to 1. So any of the points on the unit circle will satisfy this equation, okay? let us go over here. They're wanting us to solve the Pythagorean identity, which is this, for cosine squared. So this needs to be isolated. So that means we want to move that. So just showing the detailed work here of what they mean by that. And the whole point of doing this is just to show you that even though this is our Pythagorean identity, we are able to manipulate it and move terms around. So if I want to solve for cosine squared theta, I'm going to need to subtract sine squared theta on both sides. And therefore I'm left with cosine squared theta equals 1 minus sine squared theta. If I do the same thing for sine squared theta, I'm trying to isolate sine squared theta. So in order to get that to move over to the other side, I need to subtract by cosine squared theta on both sides. So sine squared theta, I won't show the work on this one, is just 1 minus cosine squared theta. So note, you can manipulate to isolate certain terms. Okay, just make sure that whatever you do on one side, you do it on the other side as well. So look what happens now if we take this Pythagorean identity and now we divide every single one of the terms by cosine squared theta. This is how we discover the second Pythagorean identity. So we take the initial one, which is this, and we're going to divide every single term by cosine squared theta. Cosine squared theta over cosine squared theta is a 1, plus, divide that, well, sine over cosine, if you go up here, let's shift down, sine over cosine is our tangent function. Therefore, if we have them both squared, we are going to write tangent theta, but we need to add that squared. And 1 over cosine theta, or cosine squared theta, is going to be this one, but since it's squared, then we have to make sure this one is squared as well. So 1 over cosine theta is secant theta, but since it is squared, I put the squared. So this is how you find your second Pythagorean identity. Put a star here. This is 2 of 3. Okay, I'm going to put a star over here to remind you that this was the first one. Again, with this Pythagorean identity, you will also be able to manipulate to solve for certain terms. Right now, secant squared is isolated, but let's say we wanted to isolate tangent squared theta. Well, that would require the 1 moving over. So to solve for tangent squared theta, the 1 went over to the other side by me subtracting 1 on both sides. Okay, so I want you to pause the video and I want you to proceed to do the next one to find the third Pythagorean identity. This time, to find the third Pythagorean identity, I want you to divide every single term by sine squared theta. So take this Pythagorean identity up here, and this time divide by sine squared theta. So pause your video now, and then come back. Okay, so welcome back. So this is what you should have done. So divide it all by sine squared. Cosine over sine is cotangent. They're both squared, so add on a square. They cancel out to be a 1. 1 over sine is cosecant. Since it's a squared, we put on the squared. And then, again, you can still manipulate this function as well. If you want to isolate the cotangent, I had to subtract 1, so I end up with that. So, as you look at all of these, let us look at some other identities, okay? So we have these identities up here, whoops, and we have the 3 that we just discovered. But I want you to notice the following. You notice how cosecant is the reciprocal of sine? This is what this means. If you want to reread this, this is like saying cosecant is the reciprocal of sine. This cosecant theta equals 1 over sine theta is this phrase. Cosecant is the reciprocal of sine. This is the reciprocal. I can also rewrite it in this way. I can also rewrite it as sine is the reciprocal of cosecant. So I wanted to introduce you the flip-flop of what you're seeing at the top of this page. Look at cosine. Let's go back to the top. Secant is the reciprocal of cosine. Secant is the reciprocal of cosine. You can also say cosine is the reciprocal of secant. Last one. Cotangent is the reciprocal of tangent. So we can also say tangent is the reciprocal of cotangent. Okay? So, what you're going to see on the next page is, see all these functions right here, the 3 of these, and all of these up here. What we did, you'll notice that we have compiled and put them right up here in an organized fashion in a formula chart. So all these right here, those up there, were these right here. There were these problems right here, and the ones that I just talked to you about down here. Okay? And then these 3 functions right here, the 3 Pythagorean identities that I just gave you here, I'll go back to that. Those are these right here. This, this, and this. Okay, so if you're wondering what these are just the manipulated versions of these. Okay, so notice right here, cosine squared plus sine squared theta equals 1. If I wanted to isolate sine squared theta, well, I had to subtract cosine squared theta on both sides, right, in order for this to disappear. So sine squared theta equals 1 minus cosine squared theta. So this and this is just the manipulation of this. The same with these, and these 2 are these. So in essence, if you really want to think about it, these are all the ones we just finished doing. This is just manipulating these. Okay? So we're going to use this chart up here to help us get done the problems that follow. Okay. So the first question here tells us, use the trig identities to write each expression in terms of a single trig identity or a constant. So you're going to be given some trig expressions, and I'm going to need you to rewrite them in one single term. So if you look at the first one, the first has tangent theta times cosine theta. Well, both of these are 2 separate terms, and we want single trig. We have 2 trigs there. So what are we going to do? Well, let's start rewriting. So let's look at tangent theta. Can tangent theta be rewritten in a different way? Well, let's look at our formula chart. Tangent theta here at the top of the page can be rewritten as 1 over cotangent theta, or it can be rewritten as sine over cosine theta. So which one of these tangents do I need to use? Well, I noticed that it's sitting next to a cosine. So which one of these has a cosine in it? This one does. So I'm going to use this one right here to substitute. So tangent theta is the same or equal to sine over cosine. So I'm going to rewrite tangent theta as sine theta over cosine theta. This cosine theta I'm just going to bring down because it's multiplying. If you want to put a dot here to help you remember, it's multiplying. And then I'm going to notice that those two cosine values are going to cancel. Cosine theta over cosine theta gives me a 1. So I'm left with just a sine theta. And that indeed is a single trig identity, which I was looking for. Let's try this one. 1 minus cosine squared theta. Let's zoom in here because that's really far. Yes. Okay. So we have 1 minus cosine squared theta over cosine squared theta. Well, let's go see if we can find this on our chart. Well, 1 minus cosine squared theta is right in the middle of our chart. 1 minus cosine squared theta equals sine squared theta. Remember, equals means they're equivalent, they're the same. So I'm going to replace 1 minus cosine squared theta with this new term. So 1 minus cosine squared theta, replace it with sine squared theta over, this is already a single term, so I'm just going to leave it. But don't we know that sine over cosine is tangent? We sure do. Formula chart tells us that sine over cosine is tangent, but the only difference is that in our problem, these are both squared. So if this is squared and this is squared, this has to be squared too. So sine over cosine is tangent theta, but we do need to put the square term because they are all squared. So that's our answer for part B. Alright, let's look to the next one. Let's zoom out just a little bit here. Let's go to part C. Part C is cosine theta times cosecant theta. Alright, again, cosines and sines, don't worry about them. Leave them as is, okay? So cosine theta is just going to come down. Cosecant theta, go up to your formula chart if you still don't know it by heart. Cosecant theta is 1 over sine, so I'm going to replace that with 1 over sine. And then I'm going to simplify cosine times 1. It's just a cosine theta. And under the cosine, there's an invisible, even though you don't see it, there's an invisible 1. The 1 times the sine is a sine. Now this looks very similar to this one. This is sine over cosine. This one's cosine over sine. So when cosine is at the top, reminds me it's cotangent. Cotangent theta. Again, look at your formula sheet at the top. But my final answer is this single trig function, cotangent theta. Last in this section, let's simplify sine theta times secant theta over tangent theta. Well, sine theta, we do not touch. Secant theta, let's see, well, secant theta, when we look upstairs, it's going to be 1 over cosine. So come over here and I'm going to put 1 over cosine. And then this big division bar goes here. Now, I'm going to have to make a decision if I want tangent theta to be written here, or do I want to write tangent as sine over cosine? Well, you have one or two options. I noticed that this right here is going to end up being tangent theta. And because this is tangent theta, I'm going to leave it as is, because look what's going to happen. I know this here ends up being sine over cosine, which is tangent theta. And this is just going to come over. So tangent theta over tangent theta, is just going to equal a 1. Okay. Now, some students prefer breaking everything down, and you can. Notice that it will be the same answer. Look at another option. So from here, you could have done, okay, well, I know this is sine times 1 over cosine is going to end up being sine theta over cosine theta. And then I'm going to put this division sign, and this here, tangent, is sine over cosine. But some people just want to break it all down. And they notice that these are identical to these, or basically you can do that. And so it equals the constant 1. So whichever method you want to use, it still works out. Okay? You don't have to have one way of approaching it. So that's an example here of a constant. Okay? So that's how you simplify expressions down to a single term. Now, down here at the bottom, we are going to take a little trip to middle school and remind ourselves of some of the rules that involve fractions. Okay, so let's take a brief look at this to refresh our memories. So when you are asked to divide fractions, remember that you have to multiply by reciprocals, okay? So when dividing fractions, multiply by reciprocals. Okay, so a reminder of what that means. So again, I'm going to zoom in because it's very small print. Let's look at the part A. So 2/3 divided by 4/15. So this here is your main division bar. Okay, so I'm going to darken it. You take the top fraction and it stays written exactly as you see it. The division symbol changed to a multiplication, so that's where I'm getting ready to multiply by the reciprocal. And the reciprocal is the exchanging of the numerator and the denominator, their placement. So instead, it's going to become 15 over 4. Reduce, cross-reduce, if possible. And what I mean by that is check to see if you have some common factors at the crosses. Well, 2 and 4 has a common factor of 2. So if I divide them both by 2. And these 3 and 15 have a common factor of 3. So 1 times 5 is 5. 1 times 2 is 2. So if you cross-reduce, you will get a fraction that's already fully reduced. Okay, if you find the greatest common factor. Go ahead and pause and do part B on your own, and then check with me. Alright, here's our answer for part B. So we multiplied by the reciprocal, cross-reduced to get an answer of 7. Now look at part C. Slow down on cross-reducing, or multiplying by the reciprocal, if you note something like this happening. Notice this number is identical to this number. They are both the same, and they are both located in the denominator. Okay, so the numbers must be the same and located in the same place. When that happens, you are easily able to just cancel them out. And so this is your main division bar. There's a 2 over what was left over in the denominator, a 3. So there's no need to do any multiplying by the reciprocal. But be quite careful, because sometimes this can mislead you to think that these both are in the denominator, when indeed they are not. Because if you rewrite this whole number as a fraction, you will notice that this 2 is in the denominator, and that this 2 is in the numerator. They are not in the same location, even though they're the same number. So you are not able to cancel. So keep the top fraction the same, change it to multiplication, and that has to do its reciprocal business. So for this problem, the answer is a 4th. So be wary of those little tricky, misleading problems. So let's use these skills that we have refreshed our minds with and work out the last 4 problems in the notes. So over here, for example, number 3, we have the cosecant of theta divided by the cotangent of theta. So cosecant, looking up at our chart, cosecant is going to be 1 over sine. So let us write 1 over sine theta. That's for the cosecant. Then we have a division, so I'm going to put a little bit darker there. And then we need the cotangent. Well, the cotangent definition is cosine over sine, so it starts with a cosine over sine. So cotangent is cosine theta over sine theta. Well, hopefully you are already noticing that these 2 trig functions are both located in the same position and they're the same number. Therefore, we can get rid of them and we're left with a 1 divided by the cosine. But this should be familiar to you, and we go up here and we look for it and we notice that right there, 1 over cosine is our secant. So we're going to come down here and write this as secant, and we're done. We have simplified the complex fraction into a single term. Let's do this again. So 1 minus cosine squared theta is a Pythagorean identity that has been manipulated, and that's equivalent to sine squared theta. So I'm going to replace it with sine squared theta over, and then I'm going to rewrite tangent squared theta. I'm going to make this a little bit darker, as sine squared theta over cosine squared theta. Notice because this is squared, I have to put squares on this one. So here I have a fraction that's dividing, so I need to write this, keep it the same, change my division to multiplication, and I need to multiply by the reciprocal. Which beautifully leads to some canceling, because that's what you're hoping to happen. And I get that simple trig function at the end. And so notice canceling is huge when it comes to simplifying these complex fractions. If you don't see cleaning up happening, you have substituted something wrong. Okay, let's go here. Cosine theta times secant theta over tan theta. We don't do anything about that. Secant theta is 1 over cosine. And then I have to make the decision, do I want to break this down or do I leave it? Well, your decision is based on this. I notice that this and this are going to disappear. So me rewriting this is not really going to help me. Actually, I should leave it. Instead of writing it as sine over cosine, leave it as tangent theta. Because it just is going to be easier to see that this is the reciprocal of what? Of cotangent theta. That's it. Now, if you did it the other way, I just want to show you how it doesn't matter if you decided to choose the other way, it would still work out. Let me zoom out. Okay, let's say you decided that you did want to split up this tangent theta. Okay, so these canceled, and you have 1 over this tangent theta. So I'm going to do this to show you. You could have done, or you could have done 1 over, and the tangent theta, you could have said, hey, I want to write it as sine over cosine. I want you to see how you will end up with the same answer. You keep this change into multiplication, and this flips. So it becomes cosine over sine, but 1 times cosine over sine is just cosine over sine, which is cotangent theta. So notice it's the same. Okay, just a little bit extra steps, but nothing all too difficult. So you're not wrong if you wanted to go that route. Okay, last one. Sine theta, we don't change it, over cosecant theta. Well, cosecant theta is the reciprocal of sine. So this is my main division bar. I always make it a little darker just to make it a point, or a little bit longer. I don't know if you've noticed that. This one stays the same. Then my dark division symbol turns into multiplication. And I remind myself with these arrows that I need to flip. Get the reciprocal. And this times this is merely sine squared theta. And that is also a single trig function. And I have arrived to simplifying the complex fraction sine over cosecant. So hopefully that helps you understand how to do these problems. What I'm going to have you guys do on the flip side is come over here and do these problems that imitate the problems that you just did in your notes. Here's your homework. Show me the work and place your answers here to the right, and submit your answers in Google Classroom as a PDF file. Thanks for watching.